Good morning, students. So welcome back. I hope whatever you have done last time you have understood and you have solved the remaining examples of that exercise. Now today we are going to study sum of the lengths of two sides of a triangle. Now before coming to that, let us do one activity. Suppose we are standing on a ground and I have drawn three non-collinear points A, B and C. I hope you know non-collinear points, collinear and non-collinear. What are collinear points? Yes, exactly. The three or more than 3 points, if they lie on a straight line, then the points are said to be collinear points. If they do not lie on the line, then the points are said to be non-collinear points. So here I have drawn non-collinear points. And I asked one of the students to start from A to reach C. So there are two ways he can go. Either he can go from A to C straight away, right? Okay? Or he can start from A, he can reach B, and then B to C. Which will be easiest way? Yes, definitely the shortest way, A to C. So he will more prefer to go from A to C. So definitely here AB plus BC is greater than AC. I hope you agree with this. Yes, definitely. Okay, now can you tell me what type of figure is this? Oh yes, it is triangle. And you can see here AB and BC and AC, I can call them as the three sides of the triangle. And what you find that if I add these two sides, AB plus BC, they will be always greater than the third side, AC. Any two sides, suppose if I take AC and AB, some of them, it should be greater than BC. And suppose if I take AC and BC, it should be greater than, it has to be greater than AB. You will agree with it. Same game you play with 3 different points, you will get the same results. Okay, so what it suggests that sum of the two lengths of two sides of any triangle is always greater than its third side. Where it is useful, we'll come to that. Suppose if I get the difference of the two sides, then what will happen? AB minus BC. Will it be greater than AC or smaller than AC? What do you feel? Oh yes, exactly. It has to be, yes, smaller than AC. It has to be smaller than AC. Okay, or suppose if I say AB minus AC, it will always be smaller than BC. Or suppose if I take AC minus BC, it should be always smaller than AB. Exactly. Right? So, two properties. Sum of the lengths of two sides of any triangle is always greater than its third side. And second, difference of any two sides is always smaller than the third side. Now, where it is useful? What do? Take sticks of different lengths from suppose 2 to 20 centimeters. You do this activity. Okay. Now, you choose any two sides. For example, I took 2 sticks. One is 5 and the other is 7. Now, I want a third stick in such a way that I should be able to construct the triangle. So, I place this like this, 5 and this is 7. So, what should be the length of the third side? How to decide? We can decide it. So, first what you do? Sum of the sides. 5 plus 7, 12. Now, I know that sum of the two sides of triangle is always greater than the third side. So, definitely the third side has to be smaller than this sum. What is the sum? 12. So, definitely the length of the third side should be smaller than the sum of this. That means it should be smaller than 12. Right? It should be smaller than 12. Now see difference. 7 minus 5, 2. Now we know that difference of the two sides is always smaller than the third side. That means the third side should be greater than this difference. It should be always greater than the difference. So difference is 2. So third side should be bigger than 2. So it can be 3. It should start from 3 to 11. So it can be within the range 3 to 12. Right? So any length 3 to 12, between 3 to 12, you take the stick of that any length, you will be able to form a triangle. So that is what the use of these two properties. Sum of the lengths of two sides of a triangle and difference between the two sides of a triangle. Now I am going to draw one triangle here and we are going to see it. Okay, let us do that, and you will do that at home also. This is another activity. Okay, now this is third activity. So here I have drawn one triangle. Remaining two, you will do them in textbook itself. Okay, so I have drawn a triangle PQR. I have drawn of exact length. This is 5 centimeter, 7 centimeter and 11 centimeter. So name of the triangle PQR. What is the length of PQ? It is 5 centimeters. Okay. Then length of QR, it is 11 centimeters. Okay. And length of RP, it is 7 centimeters. Okay. Now PQ minus QR smaller than RP. What is PQ? 5. Minus QR, it is 11. And is it smaller than RP? RP is what? 7. Now 5 minus 11, minus 6. Now minus 6 is smaller than 7? Yes, it is. Then dash plus dash greater than dash. So suppose if I bring it like this, if I add them together, PQ plus QR. Now PQ plus QR, that is 5 plus 11 and RP is 7. Now 5 plus 11 is 16. So PQ plus QR, is it greater than RP? Yes, it is. Okay. PQ minus QR is smaller than RP. Am I right? Okay. Is it true? Yes. Right? So on yes, you will tick mark. Now see the next. QR minus RP. What is QR? 11. What is RP? 7. 11 minus 7, 4. Then, is it smaller than PQ? PQ is 5. Is it smaller? Yes. Then, next we will see QR plus RP. What is QR? QR is 11. RP is 7. So, 11 plus 7. Yes, exactly, 18. Now, 18. Is it greater than PQ5? Yes, it is. So, it is greater than PQ. So, what you will say? Yes. Tick mark on yes. Then, RP minus PQ. What is RP? 7. Minus PQ. 7 minus 5. 2. Right? And is it smaller than QR? QR is how much? 11. Is it smaller? Yes, it is. Then, same way. Now find the sum. RP plus PQ. What is RP? 7. What is PQ? 5. 7 plus 5, 12. Is it greater than the third side? RQ? Yes, it is. So we can say, yes, it is greater than QR. And what you can say here? Yes. So similarly, first and third activity you will do in the notebook, textbook itself. Okay. Now, from this what you conclude? That to decide whether a triangle is possible or not from the given lengths of the side, what is sufficient? Sum of the two sides is always greater than the third side. This property is sufficient to decide from the given lengths whether we can construct a triangle or not. But only if two lengths are given and we are supposed to find the third length. so that the triangle is possible. For that, what you need? The difference between the lengths as well as the sum of the two lengths. Okay, so these both properties are essential when you need to find the range of the length of the third side. Do you get it? So let us go to the examples and solve some of them. Okay, now see, suppose if these are three lengths which are given, 10 centimeter, 5 centimeter and 8 centimeter. Now you are supposed to find whether a triangle is possible or not. So which property you are going to use? Yes, sum of the lengths of two sides of a triangle is greater than the third side. So for example, 10 plus 5, 15. Is it greater than 8? Yes. Then 5 plus 8, you have to check for each and every possibility. So 5 plus 8, 13. 13 is greater than the third 10? Yes. And 8 plus 10, now the third possibility. 10 plus 8, 18. 18, is it greater than 5? Yes. So here I can construct the triangle. I can construct the triangle because in each case I find that sum of the two lengths is greater than the third side, and hence it is possible to construct the triangle. If it does not come, then we cannot construct. Okay. Now suppose if it is asked, suppose if it is given like this, 7, 4, these are the two sides, and you have to find within which numbers the third side fell, the length of the third side fell, so that you can construct the triangle. So first what you will do, by the first property, find out the sum of the two sides. So 7 plus 4, 11. Now we know that sum of the two sides should be always greater than the third side. So definitely the length of the third side should be smaller than 11 centimeter. Now find out the difference. 7 minus 4. Now 7 minus 4 is 3 centimeter. Now we know that difference between the lengths of any two sides of a triangle is always smaller than the third side. So definitely the third side, the length of the third side should be bigger than this 3 centimeter. So what it means, that the length of the third side is between 3 centimeter and 11 centimeter. I hope you understand. So same type of examples we can solve. Okay, so let's move to the exercise now. Now exercise 6.4, question number 1, what it says, that is it possible to have a triangle with the following sides? So we have to check whether such triangle is possible or not. So for that we are going to use the number first property, that sum of the sides should be, sum of two sides of a triangle should be always greater than the third side. Okay, so we will say that if such a triangle is possible, if such a triangle is possible, then sum of lengths of any two sides of triangle should be greater than the third side. Okay, now what are the lengths given? 3, 6 and 7. So 3 plus 6. 3 plus 6. That is how much? Is it greater than 7? Yes. 9 is greater than 7. Okay. Then 6 plus 7. This is first case. I'll say it as A. Okay. This is B. Then 6 plus 7. Is it greater than 3? Yes. Okay, that is 13 is greater than 3. And see the C part. 7 plus 3 or 3 plus 7. Is it greater than 6? Yes. 10 is greater than 6. So here sum of lengths is greater than the third side. Sum of two sides of triangle is always here. It is greater than the length of the third side. Hence, what we can say, therefore, the final statement, therefore the triangle is possible. Therefore the triangle is possible. Do you get it? Okay. Now, let's move to the third example. Okay. Now see third example. This property I have not rubbed. I have kept it as it is. Third example, 6 centimeter, 3 centimeter and 2 centimeter. So if such a triangle is possible, then the sum of lengths of any two sides of triangle should be greater than the third side. Right? So let us check. So first possibility, 6 plus 3. Is it greater than 2? So 9, it is greater than 2. Yes, it is possible. Then, second, 3 plus 2. Is it greater than 6? 5, 3 plus 2 is 5. Is it greater than 6? Oh no, 5 is not greater than 6. So what can I do? It is not possible. Right? So 5 is not greater than 6. Rather, 5 is smaller than 6. Do you get it? So here sum of two sides is not greater than the third side. So from that what we can say? Yes, therefore the triangle is not possible. But we will try for the third side also. Let us check for third side. What is the third side? 6 plus 2. Is it greater than 3? Yes, 6 plus 2 is greater than 3. Right? So, what you can say, therefore, the triangle is not possible. Okay? Therefore, the triangle is not possible. Okay? Now, let's move to question number 2. Now see second, take any point O in the interior of a triangle PQR and is, first one is OP plus OQ greater than PQ, second one is OQ plus OR is greater than QR and third one is OR plus OP greater than RP. So from that I am solving second one. Okay, and I have drawn the figure here. O is in the interior of the triangle PQR. Okay, now here what it is said, OQ plus OR, OQ plus OR should be greater than QR. So how to do that? So for that what I can do this construction in this way. Join this. You can join this also. So all the three examples you can solve. Now the example I have taken is related to which triangle? Now what you get, these are all triangles. Now can I solve? Yes, I can. Okay, so this is OQ, this is OR and this is QR. So which is that triangle? Triangle OQR. Right? So in triangle OQR, we are talking about this triangle. Okay, we have to show that OQ plus OR is greater than QR. Now which property? We know that if triangle is possible, then sum of the lengths of two sides of any two sides of a triangle is always greater than its third side, right? So here, therefore, OQ plus OR is greater than QR. Is it true? Yes, it is true. Okay, that is what you are supposed to write. Now, let's move to the fourth example. ABCD is the quadrilateral and we are supposed to find is AB plus BC plus CD plus DA greater than AC plus BD. Now, we are going to use the same property. That is, if the triangle is possible, then sum of the lengths of any two sides should be greater than its third side. Okay, now, so first we are going to consider triangle ABC. So, in triangle ABC, what you will get? AB plus BC is greater than AC. Okay, this is first step. Okay, then come to triangle ADC. In triangle ADC, CD plus DA. Okay, so CD plus DA is greater than again AC. Okay, this is property second step. So you are coming across the same length AC, diagonal, same diagonal. Now I want the next diagonal BD. So again I have to consider this triangle. Now I will consider triangle ADB and then I will consider triangle DCB. Okay, so in triangle ADB, what I will have? DA plus AB is greater than DA plus AB. It is greater than, yes, of course, length BD. Third step. And then I will consider triangle BCD, that is this triangle. In triangle BCD, what I will have? BC plus CD. Length BC plus CD is greater than, yes, BD. Okay, this is step fourth. Now, what we want? AB plus BC plus CD plus AD, right? So, add all this together. Add 1 to 4, right? So, adding 1, 2, 3, 4. Adding 1, 2, 3 and 4. We get. So, what we get? Okay, so I'll have AB plus BC, okay, plus CD plus DA, right, plus DA plus AB plus BC and plus CD. That is greater than AC plus BD plus BD, right? So that is greater than AC plus BD plus BD. Okay. Now, so therefore, see here, AB, so 2AB, BC, so plus 2BC, then CD, so plus 2CD, and plus DA, so plus 2DA. It is greater than AC plus 2AC, and here BD plus BD, 2BD. So what is common here? 2, and here 2. So I can have 2 in bracket AB plus BC plus CD plus DA greater than 2 in bracket AC plus BD. Okay. Now dividing both sides by 2. So what I will get? Therefore AB plus BC plus CD plus DA is greater than AC plus BD. What we did? Dividing by 2. Dividing by 2. Okay. So is this possible? Yes. Hence what we can say? Therefore yes, AB plus BC plus CD plus DA is greater than AC plus BD. Okay, so that's what it is required. I hope you have understood. Now let us move to the next example. Now see sixth example. The lengths of two sides of a triangle are 12 centimeter and 15 centimeter. Between what measures should the length of the third side fall? Okay, so this is sixth. Now we know that sum of any two sides of triangles is always greater than the third side, right? That means the third side is smaller, should be smaller than this. Okay, therefore the third side is smaller than the sum. What is the sum? 12 plus 15, that is 27 centimeter. And second property, that is the difference between any two sides is always smaller than the third side. Also, difference between any two sides of a triangle is always smaller than the third side. What it means? Therefore, the third side is greater than the difference What is the difference? 15 minus 12, that is 3 centimeters. Okay, so third side should be greater than the, or should be more than the difference. Okay, so here we will write more. Therefore, the third side is more than difference. 15 minus 12, 3 centimeter. And so, our final answer. Therefore, the length of the third side. Therefore, the length of the third side could be any length greater than 3 centimeters and smaller than 27 centimeters. Okay, that is what the required answer is. Okay, so dear students, this exercise is completed here. I hope you have understood. Try to solve the remaining examples, and if there is any doubt, try to contact me. Now